let's revise some basics of a graph first. I'm sure you have seen this from SPM. So this is what we call a sine function. So sine function start from 0, and this is what we call a one complete cycle, which is 2 pi radian or 360 degree. And this is what we call a negative sine function. It will start from a negative part. This is what we call a cos function. Okay, start from an amplitude and move in one cycle. And what about negative cos? It start from negative 1 here, and then it's going to go there, here. And this is what we call a negative cos function. So I hope you remember, sine positive look like this, negative signs is the inverse of the positive. The same thing here for the cos and negative cos. Remember again what is SHM. SHM is a periodic motion without loss of energy, so without any damping. So let's say I have a bouncing spring moving upside down here. So it appears, even though it's moving upside down, if we're going to plot this in terms of a t time, so it's going to appear like a sinusoidal function. So this sinusoidal function that we are going to use later. First, we're going to see a graph of displacement times x versus t. So we know that from general equation, x equals to a sine omega t plus phi. Remember what a is? A is amplitude. Okay. Omega is the angular velocity. And here, what is this? This is what we call initial phase. So initial phase means what is the starting point of the vibration or the simple harmonic motion. In my case here of the pendulum, I start from the number 1. So this is where I say this is my starting point. So here, if phi is 0, okay, phi 0 means it start from number 1. Thus, you put this one as 0. Okay, you end up with x equals to a sine omega t. So this is a function of sine. So you have x versus t, and this is your sine function. Okay, one complete cycle is t period. Next, let's see graph of velocity versus time. From the general equation you learned from previously, v equals to a omega cos omega t plus phi. Alright, now this is what we call the v maximum. Okay, v maximum value. And this is our angular velocity, and this again our initial phase. Now let's check what is my initial phase. I want to use location at number 1 as my initial phase. So if I'm using location 1, that means the phi is 0 there. Okay, phi 0 means no initial phase. Okay? There is no starting point except from the equilibrium. So if this is 0, then you're going to end up with v equals to a omega cos omega t. Okay, this is what function? Cos. So you have a graph of v versus t with the cos graph. Alright? Now, this is, you have to be careful. Here is what we call a maximum value. So take a look at your equation. We have a omega as our maximum value. Okay. Next, we also have a graph of velocity against displacement. Okay, it's different than before. Before this, we plot graph v versus t time. Here, we're going to plot graph v versus x. So which equation we're going to use? I'm going to use equation that have v and x. So this is the equation. V equals to plus minus omega a squared minus x squared square root. But this is the equation that's going to be a problem for me if I want to plot a graph with this part. So what I'm going to do here, I'm going to square both sides. Okay, square both sides. And then you end up with this equation. Now, a squared and this a squared is actually a squared over a squared is 1. So don't worry about that. Bring this part here to the left hand side. Okay, v squared over omega squared a squared. So I have a squared divided by a squared. I'm going to get 1. X squared divided by a squared. I'm going to x squared over a squared. Now rearrange equation again. I'm going to put 1 here to the right hand side and everything and the rest to the left hand side. So if you pay attention to the equation here, you're going to see this is what eclipse equation looks like. So I'm sure my graph of v versus x is an eclipse graph. Okay, this is our eclipse graph where this is my amplitude A and this is my negative amplitude A. So you're going to see an eclipse graph instead of a sinusoidal. Last one, we're going to see graph of acceleration against times. So the general equation from previously is A equals to negative A omega square sine omega t plus v. So I'm still using the same location at this location where I don't have any initial phase. That means phi is 0. Okay, and if you plug in that 0, you're going to get A equals to negative A omega square sine omega t. So what kind of graph here? Negative sign. Okay, be careful. This is what we call a maximum acceleration. And we have a function of negative sign. So negative sign is this graph. Okay.